Attention, ladies and gentlemen. On a scale from 0 to 10, please, how is my audio? Hello, Joseph Ayala. Hello, Vindra. Vindra is one of the students. How do I say that? Vindra is one of the most engaged students in the history of Lean Six Sigma. It's impressive. It's impressive to see masterclasses, open Q&As, yellow belt, if I am not wrong, like green belt, white belt. That's wonderful. And I know that other people are also coming here to these sessions very frequently, and I am so happy to have all of you guys here. I can see Kandasamy, I can see Mpume, I can see Kagalelo. Thank you so much for being here. And this is an open Q&A. So if you are a master black belt, you are very much welcomed. If you are a black belt, you are very much welcomed. If you are a green belt, this place is for you. If you are a yellow belt, I am happy to have you here. If you are a white belt, you are very much welcomed. And if you don't know nothing about Lean Six Sigma, it's okay too. You are very much welcomed, okay? By the way, Lean Six Sigma is a powerful method to help you analyzing and solving what we call systemic problems where the causes are unknown. Yes, some problems we can say, the causes are known. Yeah, if I want to drink some water, I am trying to drink some water, but the water is not coming up. This is a problem because I need some water, But in this case, the solution is very known. It's very much known. I just need to open up here and then I can drink some water, But unfortunately, in this planet, there are many problems do not have, a known solution, do not have a known root cause, and as a consequence, these problems do not have a known solution. Meaning, we cannot simply brainstorm, we cannot simply invite people to a meeting room and let's talk about potential solutions. Don't do that. For systemic problems, please don't do that. Don't do that. Because you'll be wasting time, wasting energy. You need to use a more, let's say, I don't know if I like this word very much, but it's a more sophisticated, method. It's a method, a method, a recipe, a framework. You need to, first of all, identify the voice of the customer. First of all, identify your customer, segment your customer, prioritize your customers, and then identify the most critical customer segment. Listen to the voice of the customer, prioritize the voice of the customer, translate into something that is measurable. Then you need to measure the size of the problem, and then we need to map the process. We need to map out the process. We need to minimally understand the current state. Then we need to walk the process. We need to go to Gemba, workplace, yes? And then we need to talk about root causes. Because you can be sure, problems have causes. Sometimes, again, it's hard to identify, but they do have causes. It is possible to find what we call causal relationship, yes, y as a function of x. So let's see, our problem is a function of what? Percentage of burnt cheese bread is a function of what? Of the quality of the oven, of the quality of the recipe. And by the way, it is beautiful. It's so exciting when you find the vital few factors that are truly important to a certain y, to a certain variable. Yeah. After that, you'll be implementing corrective actions and implementing solutions to actions to maintain the positive results. Yes. So in brief, this is Lean Six Sigma, and we have a framework named DMake that is very, very much powerful. Yeah. And once again, I am completely passionate about this method, because this method changed my life completely. My entire career was built based on this method, and then from 2010 on, so from 12 years, 12 years back, I started operating not only as a practitioner, yes, and I keep being a practitioner, but I'm also operating as an educator, yes, and so I can multiply the benefits that happened in my professional life to the lives of many other people. And right now, we have more than 50,000 students across the globe, the vast majority for free, yeah, the vast majority, what we call white belts, that is the very first level, yeah, and we do have yellow belts, green belts, black belts, and master black belts too. And it's an honor, it's a pleasure to have the chance, the chance that you guys are giving me to be your educator and to add a little bit, to your professional career. So on top of everything, thank you so much for giving me this opportunity, okay? And now all questions are welcomed. Please drop here your questions. All questions are good questions, okay? There is no poor question. All questions are welcomed, okay? Thank you, Vindra. Thank you. Hello, Zinasman. Hello, Faduski. Hello, Samuel. Greetings from Ghana. That's amazing. South Africa. That's amazing. Why normal distribution is very important. So we have a question from Zinasman. Why normal distribution is very important, that we need to confirm it using histogram? Vitamins. So let's talk about Germany. And then we need to talk about a guy named Gauss. So Gauss proposed a very interesting concept, very interesting concept. Yeah. So take a look here. I hope you guys can see. Yeah. I hope you guys can see. It looks like a bell. A bell. Yeah. That's why we call bell-shaped curve. Yeah. That is the shape that we will find on what Gauss from Germany proposed as normal probability distribution. And why normal? Zinasman? Because many, and maybe we can say the vast majority of the variables in this planet Earth, they behave according to a normal probability distribution. And first of all, just to guarantee that people that are new to Lean Six Sigma, they are understanding what is a probability distribution. What is a probability distribution? So let's talk just a little bit about probability. Yeah. I have a plastic piece here, yeah? On one side blue, on another side white, yeah? If I flip this piece, and then ask you guys, which color is facing me up? You know, when I look here now, which color is facing me up? You know, blue or white? And then I can ask you guys, what is the probability? What is the probability that blue is facing me up? What is the probability? Well, I do have two colors, white and blue. I was right now flipping this piece and then stopped using a mechanism that we can say it was random. It was random. Boom. So I can argue that I have two possible events, yeah? And I am interested in one event. I have blue and white, two possible events, yeah, or trials. And I have one event that is interesting for me, that is blue. So 1 out of 2, 0.5 or 50%. So I can argue that there is a probability that when I look here, yeah, the blue is facing me up. You know, there is a 50% probability that blue is facing me up. And in fact, it was blue, you know. Yes, probability, very simple, very simple. So when I say probability distribution, very simple. I am saying that I am distributing different values of probability. So there are different values of probability. There is, for example, 0.1%, and here it's a little bit, it's a little bit more, you know. Let's say 0.9, and here I have, I don't know, 2%, and here I have 4%, and here I have 5%. Wow. Then here I have 4%, then here I have 3%. You know, I am distributing many different values of probability, you know. So that's why probability distribution. And with a probability distribution, I can do basically two things. Let's say in general, probability distributions are very valuable because I can project. And when you can project, I mean, you can predict, you can infer. My dear friends, if you have knowledge and ability to infer, to predict things, there is a very high chance that you will be valued by corporate world. Because if you can predict the performance of a product, if you can predict the performance of a process, you know, to produce like many different vitamins, if you can, you know, predict the behavior of a certain operator, of a certain machine, you know, companies love that. And normally companies pay for that. Because when you can predict, you can anticipate to problems. Yeah? Modeling is the opposite of trial and error. So you can have a much better life, you know, if you know how to model processes or things, to speak very, you know, in very simple words. If you can predict how the cheese bread will be in terms of quality before baking, you know, companies love that, because then we can save a lot of money, because we can anticipate the problems. We can optimize our processes, yeah? This is a serious thing. So probability distribution has to do, on top of everything, with, it's an important element to help us to predict, things, let's say, to predict things. And we can basically predict two things: one single event, or multiple events. So I can take a look in this probability distribution and ask about, one certain event, or two multiple events. For example, if I come here right in front of my condo, and take randomly 10 people, boom, 10 people, what is the probability, or one person, let's keep it simple. I took like one person here in front of my house, what is the probability that this person, measures like 1.6 meters and up to 1.6. So I can use a probability distribution for that as well, so it's an area under a curve. This area here represents a probability, then I don't know, 17%, 18%. If I take randomly, boom, one person, there is a 17%. That's the probability that this person, in terms of height, is up to 1.6 meters, for example. So we can do these kind of things, yeah? And why normal? Because many things in this planet will behave like this. A strong concentration, in the very middle, and then the frequency, if we are talking about histogram, or the probability, if we are talking about a probability distribution, reduces when we go to the extremes, but symmetrically, because a perfect normal probability distribution is symmetric. There is a central tendency. Yeah, there is one value in the middle. And by the way, for a normal probability distribution, mean, median, and mode, they have the very same value for the perfect probability distribution, And then when we go to the extremes, the probability reduces, meaning. If I take randomly a person here, an adult here in front of my house, boom, by chance, randomly, boom. There is a high probability, very high probability, that this person, is around, 1.6 and 1.8, let's say, 1.6 and 1.8. Yeah, because then I am talking about this very middle here. Yeah. Is it possible that this person, is a basketball player? So this person, is 2.2 meters high. Is it tall? Is it possible? 2.2 meters tall. I mean, it's not zero, but the probability is very small. Is it possible to find an adult that, is 1.4 meters tall? Yes, but the probability is very minimal, So this conversation of strong concentration in the very middle, in the center, and then the probability, reduces symmetrically, this conversation is applicable to many variables. It's crazy. If I take the volume of water, if I take, for example, 100 bottles like that, there will be a strong concentration around 1.5 liters. And then very few bottles, like 1.47, very few, and very few 1.52, you know? So concentration in the middle, and then, so I was talking about which variable? Volume of water. If I talk about the diameter here, specifically of this part of the bottle, you know, the bottleneck, yes? The same thing, there will be a concentration in the certain value, and then the probability reduces to one extreme, smaller, and it's reduced to another extreme, you know, bigger. If I take, for example, the weight of you know, of a certain cream, you know, the weight of a certain cream, you know, it says 80 grams, yeah, 80 grams. I mean, there will be, if I take 100 of these, there will be a strong concentration in 80, you know, and then the probability will reduce. I will find maybe one or two, you know, with like 79.5, you know, and 80.5, yeah. Does it make sense? So that's why normal probability distribution is so popular, And histogram is an amazing graphical tool to help you having a first picture of the probability distribution. You know, histogram is very useful for that, very much useful, because normal probability distribution is very common, but it is not the only one. For example, time normally does not behave according to a normal probability distribution. Time normally does not behave according to a normal probability distribution. Time normally, it's a non-symmetric, yeah, non-symmetric probability distribution, meaning when I am waiting for my cheese bread, hello, I need 10 cheese breads, please, can I have 10 cheese breads, yeah? And then I am here waiting, and then they said to me that, you know, it will take like 10 minutes. So I'll see a strong concentration here in 10 minutes, yeah? And then sometimes it will take like 1 hour because of traffic, because of, you know, process bottlenecks. Sometimes it will take 45 minutes. This is real, yeah? Delivery time. And I don't have this very same tail to the other side. I don't have negative time, you know? It arrived like in minus 10 minutes. I do not have. So time, normally it is skewed. This is a skewed probability distribution. Yeah, skewed probability distribution. So normally time behaves according to a very, very cool probability distribution named log normal. And sometimes exponential. There are many different types of probability distribution, yes? And again, what is the function? Yeah, what is the value of a probability distribution? I mean, if I am able to find the probability distribution that explains my process, I mean, I am able to predict. I can say to my customer, picture that, I can say to my customer, hey, I hope you get your cheese bread in 10 minutes, but I just want to let you know, yeah, let's suppose I tell my customer in 20 minutes my flight is departing, for example, in 20 minutes. So if I say this to my customer, you know, I can now calculate a probability of like going back home, for example, without a cheese bread. You know, I can calculate this probability because I know how my process behaves, I do have a probability distribution, so I can predict, and I can set up front, hey, in this process, there is a 30% probability that your cheese bread does not come, or your cheese bread comes after 20 minutes. So see, it's risk management. 30%. So if I order 100 times, 30 orders I will not get, in less than 20 minutes. So see, this is management. Management has to do with predictability. Management, we are talking about two things: predictability and competitiveness. So predictability, and control, and continuous improvement to be competitive. A good manager, a good leader is always, looking to these two things. I want to have my current processes as predictable as possible. And from time to time, I want to shift to the next level. Yeah. So this is serious. Yeah. And because see, it is important to be creative. It is important to be agile. It is important to know how to operate under this in this VUCA, context: volatility, uncertainty, complexity, ambiguity. But many things, you just need to learn how to use, classic techniques to have a much better life, a much better professional life. We are talking about stopping being firefighters, because sometimes we just consider that, this is life. So I need to be, ready to adapt and to change, like 10 times a day, 100 times a week. No, many times you are tampering. Many times you are overreacting, Many times you are just guessing. Many times you are just operating on trial and error versus stopping, breathing, and using science. This is science. And I have something to tell you. This is not rocket science. This is basic science. This is basic science. Probability distribution is Science 101, simple. And today we have like many different softwares to help us. You don't need to calculate the integral, you don't need to calculate, because when we say the area under the curve, then maybe you are freaking out that, oh my God, I need to calculate to remember, what is the function, of an exponential probability distribution, and then calculate. No. You have softwares that will do this for you, and many times you can anticipate with simple science. And that's, in my humble opinion, one of the most beautiful things of Lean Six Sigma, because if you take like the handbook, this is the Master Black Belt handbook from the American Society for Quality. That is my favorite, let's say, organization, ASQ. This is the handbook for MBBs, that I am using with my. This is the literature that I am using with my MBBs, now. You will see a lot of science in here, but in my opinion, in the right doses for you, it's not science because this is fancy, because this is sophisticated and fancy only. No. It's just because we want to be assertive. We want to propose, we want to find root cause, we want to propose potential solutions that truly, address the problems, And this is very cool, very cool. Here in Brazil, I had a chance to work for Philips, and one of my first significant, um, Lean Six Sigma project that impacted, let's say, many lives, was a project related to the quality of the focus on a cathode ray tube, the old TVs, in the periphery, in the borders, Yeah, it was challenging, and I had a chance to work direct to lead a project where the final result was like the improvement of the quality of the focus in the on the periphery, of the screen. This is very cool, right? Science. We did use like creativity, the knowledge from the experts, for sure. But a lot of science. Like sometimes I still see people saying, Marcelo, tell me how how to get like these insights. You have amazing insights, you have like inspirations. And then I tell my students, no, this is not an insight, this is not you know pure inspiration. No, I was using a method. I was just following a recipe. It's a recipe you know and it does touch things like modeling our processes, and this modeling work touches this important topic, identifying the probability distributions. By the way, now in Brazil it's 9:30 a.m. This afternoon today, the topic that I'll be covering with my black belts, we have an international black belt wave going on right now. The sessions are live. The topic that I'll be covering with them this afternoon is exactly this: how to model processes that do not behave according to a normal probability distribution. So what do we do when we have an exponential, viable three parameters, log normal? What do we do? And there are techniques. We can identify the probability distribution. We can use the concept of transformation, Box-Cox transformation, Johnson transformation. We can also use, we need to check the measurement system, We can segment our data. We can, and we do have something that we call, for capability analysis, we do have something that we call non-parametric capability analysis, CNPK. It's very cool. So coincidentally, it's the topic that I'll be talking this afternoon with my black belts. Zinasman, and just to close out the answer for your question, do we need to confirm it using histogram? You can use histogram, but my recommendation is, in order to confirm, to truly confirm if your data behaves according to a normal probability distribution or not, is a hypothesis testing. Run a hypothesis testing. My recommendation is Anderson-Darling, and then if p-value is greater than 0.05, then you can assume that your process behaves according to a normal probability distribution. Okay, there are other normality tests. Okay, Ryan Joyner, Komogorov, but my recommendation is AD, Anderson-Darling. Okay, and you can easily find normality tests in many softwares. I don't know if Excel, I think Excel has these too. but you can find this on Minitab, on Jump, on Sigma Excel. Okay, let me know if it was helpful, please, 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 please. Yeah, and let me see the other questions. For government service industry, how can one get buy-in for process improvement projects where there is no present want at the management higher level to improve? Also, being a government service, the cost of the process, worker pay, cost of service, cost of process taking longer than it should aren't really available. Okay. That's what we call the $1 million question. Yeah, because see here, here we have an interesting situation. Okay, let me talk, Vindra, about one extreme, that is where is the, let's say, the Disney, like the you know the easiest environment, to apply OPEX methods, operational excellence methods. For example, Lean Six Sigma. It is manufacturing. So automotives. That's why Lean Six Sigma is so popular in automotive sector. Auto parts and. But the problem is the volume of opportunities very much reduced. Why? Because we are talking about very mature processes. So for manufacturing, maybe now we have like on spot pharmaceutical industry. I would place as a, with an amazing volume of opportunities. It's amazing because the processes are repeatable, high volume, beautiful, wonderful. Yeah. And then many people think that, okay, Lean Six Sigma is only for manufacturing. No. I had a chance to work 7 years for a service company, and it was the best. Let's say, if I compare versus the 12 years in manufacturing, these 7 years were like, in terms of final results, were much more significant than my 12 years in manufacturing. 5 years for Philips, 7 years for Delphi. Why? Because the volume of opportunities is insane. But what's the challenge in service, including government? Yeah, what's the challenge? Normally, power games and politics, this variable is much harder, much stronger, and processes are not as visible as they are in manufacturing. So it's harder to go to Gamba. Yeah. And how do you dribble that? 3 recommendations, Vindra. 3 recommendations. You must explore the creation of alliances with people. So many times it's better to be kind than to be right. Yeah. So in service, the need, the abilities, like to connect, soft skills, the ability to connect to people, is way more critical. It is very much critical. Camila, obrigado, Camila. Olá, Brasil. I love you guys too. Thank you so much. And I can see Bakai, I can see Harold. Thank you so much, guys. So, see, many times the critical potential calls will come from a person, talking to you on a lunch, on a coffee, drinking some coffee. So, see, you will be validating with data, with science, but for service, the entry point, it is people. It's pretty much people. Because in manufacturing, I can just sit, and observe the production line and collect data, and I can reach out to some, I can find out some amazing things. For service, it's, I don't know if this is very much adequate to say, but it's with love. With service, it's easier to hide things. Because when we talk about Lean Six Sigma, we must reach what we call stinky fish. Stinky fish. This is an expression like from the fisherman. Like the fish that is in your pocket and it stays there. So it smells terrible. Like we need to reach, we need to touch. The problematic areas, the problematic things. So my first recommendation is you need to explore, like contact with people, and then having lunches, and proper, coffee breaks, and talking to people and building, alliances. Second, you must find, Vindra, one leader. You must get the buy-in from one leader, that sponsors your project. Yeah, and then you need to use techniques. For example, what's in it for me, what's in it for them, or for him or for her. You need to articulate that you must have a sponsor, a champion from your project. Because in manufacturing, sometimes you can just move on with your project with let's say, moderate support, but for service, no. For service, no. And mainly for, government, like institutions. I had a chance to mentor one big project recently on a public university here in Brazil, And that's it. The volume of opportunities, the volume is huge, but it's harder to touch and it's harder to implement. Yeah, but it is possible. It is possible. Connecting to the right people, like articulating a proper buy-in from at least one, senior leader, one senior leader. Yeah, one senior leader. And the 31, when you go to implement your solutions, the solutions must come from them, not from you. And this is hard, because normally we belts, we love to play hero. Yeah, we love to show that we, and I'm saying this as a person that makes this mistake until today with my team. Many times I need to stop and say, the solutions must come from Carlos, from Carlitos Nunes, from Taina, from Serafim, from my, from my team members, not from me. Because if I am giving the solutions, the results are not sustainable. Because then they will just wait until Vindra comes up with another amazing idea, So you must operate almost as a therapist. You must ask the right questions in order to instigate, in order to inspire, the experts, for them to come up with the solutions. Okay, so three recommendations. But you are definitely in one of the best places to be in terms of operational excellence. When we talk about opportunities, okay? Algeria, that's amazing. Thank you so much, Nassar. Thank you so much, Nassar. Very much engaged to Botswana. Thank you so much. Are you gonna have another project management workshop? I still don't know, Gugu. I hope, yes, we will have. I don't know when. We will have. I don't know when. Yeah. Project management workshop, guys, it's a workshop exclusive to white belts, okay, certified white belts that we had. It was amazing. It was super cool, right? Yeah. How How do we make it possible to pay up for green and yellow belt without... Okay, guys, this is a admin. Yeah, I don't know all the details because the payment process is completely outsourced with Hotmart. Yes, that is our partner. What I know is that they do not take a debit card. Yes, only credit card. But unfortunately, I am a I am an expert in Lean Six Sigma. I don't know about the payment process, and this is really with Hotmart. But you guys can check on their website and everything. Okay, I am so sorry. I know many countries like Nigeria, they operate with debit card only, and as far as I know, it does not work with Hotmart, right? And I think there is an option on PayPal and things like that. But you guys can check on the Hotmart website, and I am truly sorry about that, guys. Okay. Hello, Prof. I sincerely appreciate your kindness to help in boosting our career. It's my pleasure, Adeolo. Thank you so much for your words, and it's my pleasure. I love to be here and to operate as an educator, and thank you so much for the opportunity you guys are giving me to be your mentor. Yeah. How can I register for the yellow or green belt? At this point, registration process is closed. Yeah, and I don't know when we will have another wave coming up. Hopefully soon. Okay, hopefully soon, Joseph. Yeah. Thank you so much for your interest. Yeah. Yeah, the sessions for green belt are recorded. Yeah, are recorded. They are all 100% in Hotmart. Yeah, 100% in Hotmart. It's my pleasure. For black belt session, how to join? Yes, so black belt registration is now closed too. So hopefully soon, if you guys have wanna be notified about yellow, green, black belt, please email us at support at mftreinamentos.com. support at mftreinamentos.com, and then you guys will be informed as soon as we open up for registration. Okay, Bruno, how best is influential statistics cause to me? I feel like you can miss out in the Joseph, I have like my classic example for that is, if you think that influential statistics you'll be like missing out data, or not having an incomplete picture, remember your blood test. When you go for a blood test, you do not ask them to extract 100% of your blood. Yeah, just part of your blood, and it works pretty amazingly, right? So this is a good example of the power of inferential statistics. It's just a matter of being diligent in the sampling, strategy. Yeah. So there are some criteria, important criteria that you need to meet. Yeah. How do you get buy-in from stakeholders when there is little support from leadership? Google, please select just one leader, and map out completely what's in it for him, what's in it for her, and then based on that, you find a project that is strongly connected, to his or to her voice. Yes, and obviously it must be connected to the voice of the customer as well. Okay. You touched my heart in your response. Thank you so much. I'm glad to know that. Yes, white belt, there is one starting next Monday. Okay, next Monday. So check out in our website, mftreinamentos.com. We do have a white belt starting next Monday. Okay, mftreinamentos.com. It is free of charge. Is there going to be another? Yeah. I had registered for the yellow belt. What's the next step? Wonderful. Yes. So the next step is green. is green. So email us at support@mftreinamentos.com. Yeah, guys, it was an immense pleasure to be with you all. I hope you had a wonderful rest of week. Thank you so much for your questions. I hope the answers were helpful for you all. Let's keep up in this journey, of operational excellence, because for sure there is so much we can do, to help processes, people, our customers, our stakeholders using this fantastic method that is Lean Six Sigma. It's always a pleasure, and I am looking forward to meeting you all again on another opportunity here on YouTube. Bye bye. Thank you so much.